2, 1. So then I went to a hybrid.
Well, my name is John Norman, and I'm here at 23B Hackerspace, and we're at Sparklecon, a free hacker convention we're doing right now. It's January, third week of January, and we've got a bunch of people here doing all kinds of hacker maker stuff. I thought I would demo a product we actually created out of our hackerspace called the Open Access. It's actually in the 4th revision, and this is a full access control and automation security system that was built from scratch. We had the problem when we got our space that we needed to pass out keys to people, and quickly found out that was difficult. It got out of control. We really wanted to be able to have things like limited hours, auditing, and revocation. So we basically looked at commercial systems, and none of them were very good. They were either very expensive to get enterprise features, or they were very proprietary and couldn't do much, and there's no software interface or anything. So I actually created this device to use commercial RFID readers. Could be HID, MyFair, or NFC. I'm using these EM4100. They're kind of like a knockoff of the HID type, but they're an open IEEE standard. And we basically have this board. It has an Arduino compatible on board, a 2-amp switching power supply, which can power the board, some off-site accessories, as well as a Raspberry Pi, which I have bolted on here. Has a real-time clock, an RS-45 interface for talking to the outside world or chaining up to 32 of these together, surge protection and overvoltage and other types of protection on all the inputs. And there's also the ability to switch this between being interfaced with a USB cable and an off-site server, or the internal UART in a Raspberry Pi. It also powers the Pi. And it's also got 4 relays. It's got 5 monitored alarm zones and inputs for 2 RFID readers. So I created this little demo case to kind of show this off, and the wiring and everything is a little bit mysterious to a lot of people. But basically, the way most of these systems work, you have these readers, and they're just an off-the-shelf item. They've got, they typically run on 12 volts. You've got a power, a ground, a 0 line and a 1 line. That's at D0 and D1. And those are actually, the zeros are transmit on one, and the 1 is transmit on the other. It's an old format called WIGAN 26 or WIGAN 34. There's different formats. But what they basically do is they hold those lines high at 5 volts, and they drop for somewhere between 20 and 400 microseconds to signify a 0 being sent or a 1. The way you know it's a 0 or 1 is that only the 0 will be going low, but the 1 will stay high, and then there'll be a longer pulse in between data. Very old. This format is also compatible with other formats like ABA, magstripes, stuff like that. That's called clock and data. There are other ways that you can send other data on here. Now, because we're using Arduino, it has 4 hardware interrupts. Each of those readers requires a minimum of 2 hardware interrupts. So it's really not practical to put more than 2 readers per board. And 2 readers and at least 2 relays is standard for a commercial access control system, 1 board per 1 to 2 doors. Beyond that, you start to have long cable runs and it gets more difficult. So some of the features of this, like I said, it's Arduino compatible. We have an Arduino firmware stack that you can download and modify and customize. We have the ability to webify it with a Python GUI, shell scripts, wherever you want to monitor, send SMS messages, remotely control and like unlock doors. We can do all that from the Raspberry Pi. Store it in the flash card or upload to a server, whatever you like, interface with a camera system. And I'm just going to show you a little bit of how this works. So when you get one of these boards, we sell them at wallofsheep.com. They're $199. We've sold a bunch of these to co-working spaces and other hacker spaces that want something they can do basic security and access control with without spending a lot of money, and they want to be able to customize it. You're going to get one of these boards. It's going to come in a static bag. I'll usually have the battery installed for the clock, and you may need to set it to your time zone. But basically, you get one of these, you hook it up to a 12-volt power supply, screw on some screw terminals. Only needs about half an amp, so a pretty small power supply. If you get the optional Raspberry Pi kit, it comes with mounting hardware and an expansion connector that powers it, as well as hooks it up via serial. And it does have a jumper on board where you can switch it between initial programming. You typically just hook up to a USB cable, and it's just like an Arduino. It has a serial interface. You can talk to it. You can upload code via the standard Arduino programming suite. And if you want to attach the Raspberry Pi, You basically attach it, and then you flip this jumper to control it with the Raspberry Pi. So the Arduino can talk to either Raspberry Pi or the serial USB chip, like an Arduino uses, your choice. Once you get that on there, you can download the software, our site, accxproducts.com. ACCX, that's Alpha Charlie Charlie X-ray, accxproducts.com. We have a wiki with all the software. There's also a Google code site. It's called Open Access Control. And you basically open a standard Arduino sketch, and it's got the code, which you may or may not need to customize, and a little header file. And that header file lets you do things like tell it what kind of board you have, because we have had other revisions of this, a revision number if you change your software, the baud rate you want your serial to work at, like maybe it has to connect to a terminal concentrator or some kind of old computer that supports only low speed. You can set some super users that you can never delete in case you're worried about locking yourself out of your space during development. And then a password for privilege mode. This would be kind of like if you ever used a Cisco router or a switch where you have a basic read-only mode, and then you have an administrator that can actually change things like log in and open doors or add users. So you just go through this. You can also set a few things like how long you would like this door to be unlocked when you just do an unlock and don't want to leave it open. 5,000 is 5 seconds, 5,000 milliseconds. Sensor threshold. This actually has the ability to use analog inputs. When you hook up, say, a motion detector or a door switch, you can put multiple of those in series so that any of those breaking the circuit will trigger it. You can also put a resistor in line and a termination resistor and then you can train the alarm what is a normal value when it's all buttoned up, so that if that circuit is either opened, closed, cut, or shorted, it can detect any of those states. So you can have like a tamper or a fault detection. And the way it knows that is you have to tell it how much, it goes from 0 to 255, what it measures. It's an 8-bit number that it measures the current voltage coming out of the loop. And it knows, you can basically set how sensitive it is to a fault. 100 is pretty safe. It'll typically either be almost all on or almost all off, but you can set it to be much more sensitive if you really want to be very tamper evident and fault detecting. And then there's also different card formats. There's a 0, 1, you can do basically just read the first 26 bits of raw data out of it, or you can use, if you're using different cards that have like a serial number printed on them, oftentimes that serial number, it's a 32-bit number, and there are 2 parity bits in the middle, one in the middle and one at the end. And if you set the card format to 1, it will actually strip that information out, so you can just read the number off the card and type it in when you're enrolling new users. Some of the tokens you can get have that, some of them don't, like these just anonymous laundry tag type or keychains. These come in a lot of different formats. There are even glass tags that are implantable. And there are also spoof tags like this. This is a little AVR microcontroller that's clocked to 125 kilohertz, and it has an RFID antenna on it. And this thing will basically, you can program it to clone a card. So we've got some of these we were doing for testing. We use some other devices when we're messing around with RFID stuff. This is a classifier. This has high frequency and low frequency cards. And if you have an existing card you need to maybe make your system compatible with, like everyone has a subway card or an MRT or LA tap card, or maybe you have a bunch of employees that want to use their work badges after work. This you can actually plug into your USB port, and this is for low frequency tags. This is for like MyFair and high frequency tags. It's from a company called RFID. This will tell you exactly what kind of card you have, and it'll also read the serial number out of it if it's readable. Kind of a handy tool to have. But once you get this, you open up the program just like you would any Arduino program, whether it's blink.c or some kind of shield bot. You set a couple of variables in the user.h. If you want to modify any of the code, there are functions for like what each door has, whether it has just a plain reader with no keypad, or whether you want to be able to accept commands, like change the mode, like lock or unlock the doors after someone has done a valid swipe. You just compile it, and it'll work with any of the Arduino 1.0 and higher software. It's pretty fast. You upload it, And it has LEDs and the same kind of things that an Arduino would normally have, so you know it's working. I'll give it 20 seconds or so and it should be uploaded. And then, I don't know if the glare is going to be a problem, we can look at this. We can serial in with Minicom or Teraterm or whatever we like. And see, it just logged a message, the system's been rebooted. It's sort of like a syslog style. I get a little interactive menu, and I can do things without being in privilege mode, like show the date. I can show the status, whether the doors are locked, unlocked. This is great if I leave the hackerspace and I'm not sure if we left the roll-up door open or something like that. I can verify which doors are up or down, whether everything was locked or unlocked, and I can remotely lock or unlock it. Now, if I say unlock, it'll say access denied, privilege mode not enabled. So if I hit enable on 1, 2, 3, 4, which is just the password I set, now privilege mode is enabled and I can unlock all the doors. And you notice if I lock or unlock the doors, you'll actually see these relays. They have little LEDs on them. They'll change state. And you can have these do different things too. You can have it do, just unlock one door, unlock both doors. It has a little interactive menu. You hit question mark, it says help. You can arm or disarm the alarm. And you can also do a momentary open or close on one door. So it's got a lot of stuff you can do. One of the nice things about this, because it's just a dumb serial interface, when you have it all programmed and set up, you train the alarm sensors. It will basically teach the alarm what values are normal, whether there should be open, closed, or certain resistance. Once you have all that set up, you can turn over the Raspberry Pi and just remotely control it. So I can log in with SSH or a web interface, depending on how I have it set up. There's a Python GUI that MagLabs wrote. Heatsink Labs in Phoenix has a web-based management utility called Zyfler that actually shows user activity. They use the motion detectors to log whether there's occupants or not. You can adjust the AC, do different things like that with the relays and decisions off of a server. I can do things like let the fire inspector in at 3 o'clock in the afternoon when I'm at work. I just unlock the door from my phone. I have an SSH certificate on my phone. I log in, I unlock it. I can also do it with a web and a VPN connection if I want. Pretty powerful. So it's relatively straightforward. It's about as complicated as setting up, some other type of Arduino shield or something you would buy commercially. And what I would typically do is mount it in like a little metal cabinet and maybe buy some motion detectors. I would put maybe a door switch on the door. It's a good idea to be able to monitor the status of the doors so that you can detect, for instance, use it as a door chime, as an alarm that's basic. Maybe it just SMSs you or alerts your executive staff at your hackerspace or whatever you want to do. It's got a lot of programmability and features. It's very robust hardware. It's got TVS diodes that are rated 2,500 volts of surge protection, 5 amp relays made by Omron. These are pretty top shelf relays. We tried to make this very robust. And we got these manufactured right down the street at a place called AD Electronics. So these are actually US made. A place that's very friendly to hackerspace projects. They'll do runs as low as like 25 or 50 or something. And they're very tolerant and forgiving of mistakes and will help you. We also have a reset button. We have a few other little basic features like that. One thing you can also enable or disable using the reset. So you can tell the board not to accept any reset at all. If you can't reset it, you cannot upload new code to it. That can be considered a security feature so that the code on the board cannot be updated without a physical jumper being pulled. So that's useful depending on how paranoid you are. You can't poison the software image on here once you set it. People tend to, you can use these undocked with absolutely no server at all and it'll hold 200 user tags. Or you can use it with a Raspberry Pi or a server making the access decisions and just controlling it with simple commands like O for open, U and the door number, lock, unlock, that sort of thing. C for close, C0, C1, close door 1, open door 1, that kind of thing. Maybe we would like to take a look at what the door hardware actually looks like, or how we program a user. The user stuff's really straightforward. If I just scan a tag, I will see a user number, and it will say they are not found. So the first thing I can do is I can add them. I can say modify user 1. I can type in their code. I can also type in a security level, 0 to 255. I'll put in the code, which I usually just find by scanning it. If it's a tag that doesn't have any numbers, or it's something I haven't used before, I may not even trust the numbers on it. I will scan it first to see if it actually is what it says it is. They may have put the parity bits in a weird value, or maybe a 64-bit card with a parity value I can't even see, so this is what it is. So now, I just added this user, and it should actually, see now it will unlock the door. Depending on how I have the logic set. And this is, we have different users, we can set different security levels, we can do all that stuff. Let's look at some door hardware if we can, go on the road.
Quick question, Arclight.
Yes.
For the software that you're using right
Yeah.
here, you're just doing it through a terminal? Or?
Yeah, it's just through a terminal. And when it connects to the Raspberry Pi, it's just using the onboard 3.3 volt serial port built in the Raspberry Pi's system on chip. Or when it's hooked up to a USB port, it's just using serial over USB. Just 9600 baud unless you change the default. 8N1, really standard.
Don't use both the serial and the USB. I don't know that why you would.
You can use USB or Raspberry Pi, not both at the same time. But what you can do is use the RS-45 port. There's a second serial port enabled on the Arduino. It uses the software serial library. And this can let it talk to other boards. So maybe you have the Raspberry Pi server on one of these, and you daisy chain other boards to be slaves. It's just a 2-wire industrial serial port. It's used a lot in like automation machinery, and it's good for up to 1 kilometer and 32 devices.
Do you have a wireless option for making boards talk?
Yeah, in a nutshell, just use the Raspberry Pi and put a wireless dongle on it. USB
Every
wireless.
station needs a Raspberry Pi dongle and your board.
Yeah, or a wired connection, or if you want them to be completely wireless, or you have one with wireless and then you have hardwired to the next one, you can do that too.
Have you tried an Edison on that?
I haven't tried an Edison, and I want to. That's an interesting platform. At the time I started this up, this particular build was about 1.5 years ago, and the Raspberry was really the only low-power system. We tried plug PCs, we tried other stuff, and the problem with those, they're not well maintained. I mean, you may be using like some 7-year-old binaries for like the proprietary NIC card drivers and stuff. That's annoying. The Raspberry is very well maintained and open, and the Arduino is. So we've kind of been doing that for now. And I discovered the people who are not hardcore EE types, embedded programmers, Raspberry and Arduino are kind of the lowest common denominator. Software only people will touch that. Something that requires like using GCC ARM and a custom makefile or something like that really is an option for most people. The Edison though has a lot of the shrink-wrapped development environment that's ready to go, and probably a well-maintained environment. So I'm kind of looking forward to trying that. It wouldn't be hard. You can always just USB connect it to anything, even if it isn't specifically engineered for it. But yeah, there's a special header just for talking to the Raspberry. It has 3.3 volt serial level shifters so that it can talk, it's 5 volt natively, but it can talk 3.3 volt to the Raspberry.
What's the cost for your board?
199 bucks.
Okay.
We try to price it, it's kind of expensive for a hobby project, but it's significantly lower than any of the commercial grade hardware and significantly more hackable. We used USA made boards and assembly here and tried to make it very robust and still keep the cost below, like a Mercury or HID or something like that is primarily commercial market. Yeah, let's take a quick look at the doors. And